let's go into mid-value theorem that we didn't finish yesterday. It's still 4.4, okay? Chapter 4.4, we didn't finish yesterday, so we're gonna finish it. So yesterday, remember we talked about this. This is kind of like a weird shape. I'm gonna find the area of the weird shape, right? But I can make that to be what? Some rectangle shape by doing, this is my f of c and this is my a and b, right? Remember that class? So this is, so we can visually see what that means. Is everybody with me? So how about I decide to find this average height. If I'm looking for this average height, what do I need to do? Divided by what? B minus A? Am I right? Divided by what? B minus A, then I get a what? That average height, which is 1 over B minus A over what? A to B, f of x, dx. Is everybody with me now? So, we know what this means, right? This is a rectangle, this is like some curve. But I said, you know what, I need to know exactly where my average height is, where my average is, okay? So I know what my width is, I don't really care, but I need to know specifically where's my average height. Are you with me, class? In that case, what do I need to do? Just like solving for this. If I'm solving for this, I need to divide it by what? B minus A and B minus A? Then you get what? F of c is equal to this expression. So that's what I'm going to do for your next example. Is everybody with me now? How I got this f of c is equal to this? I just simply do what? Manipulation. I did some algebra. Divided by b minus a, divided by b minus a. All right. Is everybody good?
Yes.
Okay. Good?
I was just trying to figure out what this is.
4.4. We still continue from yesterday. So average value of a function. So this is what? Average value. Is everybody with me? Okay. All right. So now we're gonna use this to do our problem. So come over here. Don't worry about all that. Okay, here. I want to find, the example 4 says, find, okay? Okay. Example 4, finding the average value of a function. Find the average value of a function is this, on the interval of that. So, I'm gonna use my formula. So if I'm looking for average value, that means I do what? 1 over b minus a. That's my width. And then what? Integral a to b, f of x dx. So I'm just plugging into my formula, then I get 1 over what? P and A, which is 4 minus 1. 1 to 4. My limit is starting at 1, ends at 4, and this is my function. Take a derivative of, antiderivative of that. And everybody see this one? This is what? To the third. Let me just not skip here. Everybody see this one is what? 3x to the third divided by 3 minus 2x to the square divided by 2. Does everybody see that? So this is here, and from here to here. Does everybody see that? So 3 and 3 cancel out, 2 and 2 cancel out, and you get this. X to the third minus x squared. So this is a step they skipped, so I just put it there for you. Is everybody with me? You take antiderivative, that's why you add power and divide by 3, divided by the power. Add one more and divide by what? That power.
Where did the 1 direct come from?
This one. 1 divided by 4 minus 1. That's a part of your formula, remember right here? Are you with me? Okay. Oh, here's your, oh. All right, so everybody with me now? All right.
Kind of like about
So everybody see from here to here? All right, so if you want to, just finish up here then. So first one, will be 4 to the Upper minus what? Lower. Upper limit minus what? Lower limit. Is everybody with me? I'm simply plug it in. And you're gonna just simplify this. That will give you 1/3 to what? What is this one? 64 minus 16, am I right?
Yeah, I think so. Yeah.
One minus one is the 0. So it gives me what? 50? Am I right? 50 over 30? 4 to the third is 64, right? 4 times 4 is 16, 16 times 4 is 64. So it's not a 50, what's that equal to? I didn't subtract right, what's that equal to? So it will be 2 is 48. That's equal to what then? 16? So answer is 16, you just found it. That f of c is what? 16, we just got the average value. Is everybody with me? So we just found that average height that we need to know to make this square shape. Okay. So far so good. Is everybody with me? Okay, you gotta do your homework because antiderivative is what you go in the opposite. So you gotta remember now I'm not subtracting powers, but I do what? Add power, then what? Divide by that power. We good? You want to erase it now? You good? Okay. So everybody see that? So we got 16. So this is what the picture looks like. See everybody see it? I like it because like this is an area under the curve, but I was like, I know how to make this one to be rectangular shapes. I can just use geometry to figure it out. So I'm gonna say the height of this is what? 16. I know my width. My width is what? 3. So the area under the curve is what then? 16 times 3, which is what? 48. Yeah, 48. So I know the area under the curve is the same as what? The rectangle shape, which is 48. Is everybody with me? Okay. You see how useful this is? You can make your problem simpler if I know the average height. All right, this is very important. Second fundamental theorem of calculus. Okay, we've been using what? First fundamental theorem of calculus. When you're using a definite integral, doing a f of b minus f of a, that's the first fundamental theorem of calculus. Now I'm doing a second fundamental theorem of calculus. This is also very important. Otherwise, they're not going to call it what? Fundamental theorem, right? It's a basic is most important. All right. Earlier you saw that the definite integral of f or the interval a and b was defined using a constant a and a constant b as the upper limit and the what? Integration and x as your variable of integration. Okay, so now before we have a what? Definite a and definite b, which means we know exactly what is my lower limit. We know exactly what was lower upper limit. We know exactly which one to use. Well, how about we have a variable? We don't have x, we don't have a b, but we have x, which means changing. Okay, that's the second fundamental theorem of calculus. So look at this picture. All right, we know this one, right? This is a lower limit, and that's your upper limit. They're both constant. We know exact number to use, like 1 to 3 or 2 to 5. We know exactly the number. But now, the second fundamental theorem of calculus says the definite integral is a function of x, which means my upper limit is like a variable. It can be 1, it can be 2, it changes. Are you with me, class? So it's a lower limit is constant, but the upper limit is what? F is what? A function of x. So f is a, so I can rewrite this problem as f is a function of t. Different variables, I'm going to use it. Even though my answer is going to be f of x, but the inside of the integral, I'm going to use different variable so you will not be confused. For example, this one. I want to evaluate this function, and interval starts with 0 to x, and I'm going to choose different x. X can be 0, can be pi over 3, and pi over 6, pi over 4, pi over 3, and pi over 2. Are you with me? I have different x. So let's look at the picture. Okay, this is a picture I want to share with you. Very first one. When I choose x equal to 0, are you with me, class? So, I don't have anything, because if you plug in here, all right, if you plug in sine equal to 0, you don't have any area. All right, next one, pi over 6. So you plug in sine pi over 6, you get what? What do you get? 1/2. If you plug in x equal to pi over 4 here, you get what? Square root of 2 as your area. And what do you have here? Square root of 3 over 2 is pi over 3. And then you get pi over 2, you get what? 1. So this is actually my what? My graph, my sine graph. Remember my sine graph? This is what it looks like. You start with 0. Right here is 1/2. Pi over 4, you get a what? Square root of 2 over 2. And you have here is what? Square root of 3 over 2. And here you get a what? 1. So this is my sine graph. So as you know, when you take derivative of cosine, you get a what? Sine. Am I right? When the antiderivative of cosine is what? Sine, right? So that's why you have this. Is everybody with me? So when you take antiderivative of cosine, you know your answer is sine. So you get a what? When it's 0, you don't have any area. The x gets bigger, what happened? You get more areas, right? So this is what we learned. This is what we learned here. So the second fundamental theorem of calculus says if f is a continuous and open interval I containing a, then for every x in the interval, x is not fixed. Are you with me? It's a different number. X is a fixed. It's not a fixed. Just like the previous problem. It can be 0, pi over 6, pi over 3, or pi over 4, or pi over 2. It's not fixed. All right, that's that case. You can have this. This is what you get. Derivative of, taking derivative with respect to what? X. And then using a what? Intervals, starting with a to where? X. That comes out to be just like the same function that you have, but with what? X. Substituting this x. Almost whenever I think about this, I think about like this. Derivative and integral is what? They're opposite, right? So I feel like, okay, they can cancel out. You know, I feel like it's like a integral and antiderivative cancel out. What are you left with? F of t, but you replace t with what? X, so then f of x. That's how I see myself. Then it's kind of easier for me to understand about the second fundamental theorem of calculus. Okay? So let's look at the problem so you can kind of understand why this is so good. All right. So if I give you this problem, it says evaluate this interval, and then what? Take a derivative of that. That's what they're saying.
Right.
But I don't want to go through that hard process, because if I take a antiderivative and take a derivative, they become a what? Just whatever it's inside, right?
Right.
Are you with me, class? So I'm going to say, okay, according to this, it says I can pretty much just change this one, right? They can cancel out. I'm changing what? Is everybody with me? This is my f of t. Right? This function right here is f of t. So I will replace that with what? Which variable? X. So my answer just simply is the same thing. X squared plus 1. That's it.
So you just
I have
replace
one
the T with
question.
X?
Okay, here, watch it. What's this one? What does this one says? So remember the operation, you do what? Parentheses, right?
Right,
Please excuse
parentheses
my
first.
dear Aunt Sally, right? So if I take antiderivative of this, all right, are you with me? And then it's asking me to do what? And then take a what? Derivative of that. Isn't that antiderivative and derivative, they're opposite to each other, they cancel each other? So what are you left with? On the inside.
you
But the
replace T.
inside has what? T, but I gotta replace that with which one? An X, because now I'm using an X. So this is just X, so derivative of X is what? 1. But if this one to say X squared, then you gotta do what? 2X. So you plug in X, and then you gotta do what? Take a derivative of whatever that is, 2X. All right, so note that, we know this is a continuous function, entire number line. So I'm simply what? Replacing T with what? X. Because you do antiderivative, after you do that, then what are you asking to do? Take a what? Derivative of that. Antiderivative and derivative, they what? Cancel out. But remember, you gotta take a derivative in this step. All right? If you just have an X, derivative is only what? 1. So I don't have to do anything. But if this is not an X, say it's a cosine X, then you would, when you take a derivative of cosine X, it's what?
Sine.
Negative sine X, right? So you gotta have that in the plate. Are you in the class? Let's look at another problem. So anyway, I couldn't do this simple problem because we have a second fundamental theorem of calculus. I'm using that right now. Are you with me, class? Okay. A lot of time I'm not proving anything with you guys, but I'm simply what? Using the theorems that somebody else already proved. All right, net change. What net change means? You look at all the things and then you look at what's the differences, right? That's what net change. Like, hey, what's your net income? That means you look at your income. I mean, you look at your all the debits and all the credits, and then you look at the differences, right? That's a net. So net change, you can think of taking what? The definite intervals. The first fundamental theorem of calculus is like a net change, right? Because you do this, f of b minus f of a. All right? And then second, you do what? Same thing here. But now let's look at the problem. All right, chemical flows into a storage tank at a rate of 180 plus 3t. Okay, right? And where t is a time in minutes from this to this. And that's my problem. All right, find the amount of a chemical that flows into the tank during the first 20 minutes. Okay, so I'm not doing all the way to 80, 60. What am I doing then? Yeah, 20. So let's look at their problem. So we plug it in. Is everybody with me? They told you to first 20 minutes, so 0 to where? 20 minutes. What was the speed? What was the rate? That was their rate. So can I take antiderivative of that?
What's the
Yeah.
C term represent? The C right here.
Oh, that's your function, right here.
Oh, okay.
This one, rate. What's rate, class? Isn't it
rate?
speed?
Yeah.
Or I can say first derivative, right?
Rate is
Is everybody with me? So that's why
C.
it's using first derivative, because it says rate. Okay, are you with me, class? So I do this one, do I know how to take a derivative of that? I mean, antiderivative of that? Of course. It's 180t, and this is what? 3t squared over what? 2. And evaluate from 0 to what? 20. So this is just showing you application, part of what? First fundamental theorem of calculus. first theorem of calculus can be what? Net change problem. Are you with me, class? They're showing you, okay, let me tell you where can you use your antiderivative. Where? Net change. So this is your real problem. Look at the problem again. It says a chemical flows into a storage tank at a rate of 180 plus 3t liters per minute, where t is the time minutes 0 to 60. Find the amount of the chemical that flows into the tank during the first 20 minutes. So this is a real problem. They want to know how much chemical can flow into your storage in the first 20 minutes when you have this kind of speed. Are you with me, class? So what do we found? So after we do our antiderivative, we found how much? 4,200 liters going into the storage in that 20 minutes. So you can kind of figure out, okay, how big the storage needs to be, right? You may need to know when to stop because you don't want to put in too much, right? Do you understand? This concept gives you a lot of information that you can use when you build things. So that's another example. Let me give you another example. There's another example. Let me see. A displacement. So when you do your homework problem, you're gonna see displacement and total distance traveled. Displacement means it counts. Okay, looking at this picture. This is a positive. Are you with me, class? Where's this area? We don't call it area, but this is what? This is a negative, this is a positive, and this is what? Positive. Well, you can't say this is a moving right and this is a moving left, moving right. You can think of that way. Are you with me, class? So, when I do displacement, I do exactly what it looks like. A minus 2 plus 3. Are you with me? That's a displacement. Now look at the total traveled by the particle on A and B. Total distance is, are you with me? Total distance means, can I have a negative distance? I'm asking you, can we have a negative distance?
No.
No, that's right. Distance always has to be what? Positive. So when you do displacement, you look at your picture as is. So which one goes to the right and which one goes to left, which one goes to right. So you carry the sign. When I say give me a total distance, sign does not matter. I want everything to be what? Added. So I'll get what? A1 plus A2 plus what? A3. Does anybody get, do you see the difference between displacement and then total distance? So total distance, you become a what? Everything become absolute value. All positive. Displacement means what? It matters which way you're going. It shows your directions. So you can think of this is moving right. This is moving left. This is what? Moving right. So positive means right direction. Negative means what? Left direction. So do you see the difference? This is a good picture. So think about this picture when you do your homework problem. Why displacement is different from total distance. All right, so example. The velocity in feet per second of a particle moving along line, that's my line, where t is a time in seconds. Okay, first one, what is the displacement of the particle of time interval 0 to 5? Okay, the other one is what? What is the total distance? So, we know their answer is not going to be same because this one what? Direction matters. So which means you can cancel out some of them. But this one is what? It's all added. So I have this. I take antiderivative of that, you get that. This gives you what? What does this one give you? Displacement. Displacement, you just take antiderivative just like you've been doing. You don't care about what? You don't care about the negative one. Negative one will cancel out by itself. Total distance, you do care because you want to use negative area while going left, you gotta make it to you positive and add them together. So remember this, your displacement is only 128 over 12. Now, so particle moves 32 over 3 feet to the right. That's what they're telling you. Displacement will show you which direction you're going. If it's negative number, that means what? You're moving to the where? Left. Are you with me, class? Since you got a positive number, you move to the where? Right. I skip all this step because I believe you need to practice this. Are you with me? Take antiderivative from here. Everybody see that? T to the 3 become a 4. Second become a 3. 1 become a what? 2. Nothing become a what? 1. Does everybody see that? All right, practice that.
Maybe they simplified at the bottom.
Yeah, 128 divided by 12 is the same as 32 over 2. Yes.
So where it says 25 divided by 12 minus negative, no. What? how
This
did they
one
get those?
came from
They plugged in 1?
5, and this one came from what?
One.
Ones, yeah. This is upper limit answer, this is what? Lower limit answer. Yes. Are you following me? I skip all this step because you gotta practice. I don't need to do again and again. What you have to do is what? You have to practice. All right. So this is a displacement. So displacement will give you which direction you're going. All right?
Right.
Total distance does not, it doesn't give you which direction you're going. It's just giving you what? Entire distance you travel. Do you see the difference, class? Displacement will give you which direction you are in. You went many different places, but you end up moving is only what? This much you move to the right. Hey class, I wanted to understand this because this is like physics problem. When you do your physics, you do this kind of stuff, displacement and total distance. The displacement, remember this picture. This one you can think is moving right, this is what? Left. This is moving right. So looking at this picture, your answer should be what? Your displacement will be what? Positive number, because you move to the positive more. Positive direction, to the right direction. Are you with me, class?
There was another one down.
But total distance is different. What's the total distance? Because I gotta add all these things. I gotta make this to be what? Absolute value. Everything is absolute value. So I gotta add this distance, and then what? That distance. That's the total distance. That's how much you move, you travel. All right, so next one. Now I gotta do what? Total distance. By the way, this is what your graph looks like. So finding a total distance is a little more complicated. Why? Because if it's a negative area, or I cannot call it negative area, if it's a moving to the left, okay, then I gotta make them to be what? Positive numbers, so I can add them. So I need to have two different sections of what? Intervals. I gotta do my interval from 1 to where? 4. And another one is what? 4 to 5. Make sure this is a negative. If this is a negative, I need to make it to be what? Positive number. Are you with me, class? So, how would I know this? You need to set this,
G7 equal to 0?
yes, you need to set them equal to what? You need to set this equal, your f of t equal to what? 0, and figure out what t needs to be. That t in this case is 1 and 4 and 5, is what that is. So in other words, you gotta do factorings. Well, if you don't know how to do factorings, then you gotta do what then? I think another way we can do is what? This. When I give you this kind of problem, I make sure that I give you factoring that's what? Easy to do. Because I don't want you to spend all your time trying to do factoring instead of doing your problem. Okay? Is that fair? So, in this problem, when you factor this, you get this. So you get, which means t minus 1 equal to 0, or what? T minus 4 equal to 0, or what? T minus 5 equal to 0. So you get 3 t's. 1, 4, and then what? 5. That's what that is. Is everybody with me? Okay. So now I'm going to do what? 1 to 4, and then what? 4 to 5. Does everybody see there's a negative sign? Why do we have a negative sign? Because this is what? Negative, isn't it? So if it's negative, I multiply by negative gives you what? Positive. That's why I put the negative in here. Because you know this answer is what? Negative. So negative makes what? Positive. That's why. Well, if you want to, whatever you have this answer, you do always do what? Make it to be positive. That's another way you can do it. All right, so simply you do that problem. Do that problem again. So this is a longer, right, class? Because I'm doing a problem twice more. Because I'm taking an interval, 2 different intervals. So you do that again. You plug it as you see it. As you expected, the right-hand side, this one is what? Negative. That's the reason that I gotta put what? Negative in the front to make it positive.
Okay.
So you got 71 over 650. Do you see the differences? The total distance you travel is a lot more than displacement. Because displacement you cancel out. If you move to the right, you move to the left, you move to the right. Displacement can be 0. Are you with me, class? Why? If you have this kind of graph, what's my displacement if I do from 0 to 2 pi? What's my displacement? Nothing. Why? You move to the right this much, and you move exactly the same amount to where? To the left. So your displacement is what?
0.
It's a 0. But your total distance is different. What's my total distance? 2, that's right. Total distance would be what? 2 of whatever that is. Do you see the difference, class? Okay.